huge fan of Codesmith, and Will Sentence is a personal hero of mine. Every time I say that, I have to look over, and like, he's standing right behind me, isn't he? And but I really love what his teaching style and what he's done, and just I love talking about programming. I love programming. It's changed my life in a powerful way, and so I wanted to. I had such a good time last time. I actually reached back out and said, "Hey, like, can I invite myself to another party? Or if I invite myself, you throw another party." And fortunately, they were feeling generous that day, I suppose, and were willing to accommodate me. And so we're going to talk about a topic that I have been thinking a lot about. Is I work with new developers. So my job is I'm a VP of developer growth, and I kind of have the same job as Will and a lot of other, I think, people who've went down the education path, in that, how do we transfer what we know to other individuals so that they can acquire those skills and use it to change their life in a powerful way. And I believe that true mastery is the ability to transfer mastery. Like, I just believe that until you can communicate something in a way that you can transfer that skill set or that ability, then you don't truly know it. And so we are going to talk about really complexity and the layers that it exists in your code and how you can address that to just be better engineers. So I am going to make one fundamental assumption here, in that everybody is here because they want to be a better software engineer and that they want to write better code. So I'm making that assumption right from the gate, out of the gates, that everybody here wants to be a better programmer. And hey, the cat's out of the bag, me too. So I am constantly, every day, I just want to be better. And so we are going to do this together. And so with that said, this is going to be a semi-ambitious presentation, and I'm going to just share some things that I've really kind of honed in on for being, I would say, kind of the antithesis of what allows developers to write good code, which is complexity. And so we're going to talk about some patterns that hopefully you can take away and write better software. So with that said, I am going to, I believe I can share my screen. I hope I can. Let's go here. And hopefully everybody can see my screen. And all right, Ashley's giving me a thumbs up, so I'm going to go. And so let's get started. And we're going to do this in 3 phases. We're going to talk about local complexity, application complexity, and then enterprise complexity. And I'm going to show you some examples, and we're just going to build on these concepts. And you're going to see this kind of connected theme that, as we start to kind of weave this in, you start to realize, and really where I want to take people, is that enterprise complexity, when you're building the largest possible applications for, let's say, Fortune 100 companies, you will very quickly realize that the reason why these large applications are going poorly or there's problems is not because a lack of understanding of very complex topics, but it's a lack of commitment to first principles. And so the previous workshop or presentation that I did was really around, when I program, I'm doing 4 things. And so we'll talk about that just briefly because I have an example I want to build into. But really, the antithesis of complexity is simplicity. And so let's get into it. So I'm going to just share my screen, and we're going to kind of hop from some slides into a demo and back and forth. So I'm going to just share this, and hopefully this works out okay. I like Keynote for slides. The only problem is that sometimes it eats up all my monitors and I can't see anything. So if something goes wrong, Ashley has my cell and she can text me and be like, SOS, you've lost the entire crowd, like, come back. And then I'll do that as quickly as possible. So complexity and accelerated development, but we're going to talk about abstraction as well. And so this is just us. We're just hanging out. And I'm just going to show you the patterns and, more importantly, the mental models I use to program enterprise applications. And it's kind of the spoiler alert, it's not what we think it is that, we're not going to go far out into these high level esoteric theoretical concepts, but we're actually going to start right where we code. And so I first want to talk about local complexity. And if you want to follow along with this, we're going to do a very small refactor example at some point. And if you go to this stack blitz back here, I'll just pull this back up one more time. So it's the micro refactor example. If you want to follow along, you can do that. But when I'm writing code, I want to know, how do I know that this is high quality? And so the question that I ask myself is, how can I know the result of this code at all times? And so these are, in my mind, some of these things I'm asking is, like, immediately I look at it and I'm like, how can I know anything about this code? And that's a lot trickier than you would think it is. And then from there, I ask myself, can I reuse this code? And so this plays heavily into the concept of abstraction. And then from there, the ultimate litmus test is, can I test this code? And so, one, can I know what this code does? Can I reuse this code? And ultimately, can I test this code? And I'm going to make a very strong statement here. It is impossible to write good tests for bad code. And so if we are going to write code that is scalable and predictable and all of the ibbles that come along with writing high quality code, we have to write good code. And so if you're committed to writing tests, as we should be, then you must commit to writing testable code. And so right now, if we just ended the presentation, we're like, just take this with you. And if everybody just embraced this one concept, I feel like we've all got our money's worth, and like this would save a lot of problems. But I want to introduce what I call affectionately the axis of evil, #trademark. All right, so I'm going to show you some code, and it's going to seem fairly benign. And I've seen variations of this code over and over and over. And somebody might look at this and say, hey, like, this person actually knows what they're doing. I mean, they use fat arrow functions. Of course they know what they're doing. And higher order functions. And like, this is pretty clean code. Well, let me ask you a question. If I created a widget and I called this 3 times, 300 times, or 3,000 times with this widget, what would I get? And the answer is, we have no idea, no way of knowing. And the reason being is because there is a variable that exists within this code that affects the output of the function. And so the ringleader, in my opinion, of the axis of evil is hidden state. And so let's look at this. In the code, it comes down to the single line of code. And based on whatever mode is, you are going to get a totally different output. And so this is state that exists outside the function that is hidden within the function. This is why it's called hidden state. And you can call this method infinitely with the same exact parameter, and you will never know what you're going to get because it's dependent on state that exists outside of the function. The next one is violating the SRP. And so that is single responsibility principle. And so when you describe a function and you say, well, in recalculate total, it takes a widget, and then based on the mode, it does something, and so when you catch yourself saying, and then you go on to explain something else that it does, you have violated the SRP, meaning your function is doing more than one thing. And here we go. Here's another one, nested logic. And so when we look at this code right here, that within our switch statement, we have 3 pieces of nested logic. And then even at the bottom, we have another piece of nested logic. And so the question that I would have is, how would you test these pieces of nested logic? It's very, very hard. Because what happens is, if you've ever seen anybody show up at a movie theater and the movie's already started and they're doing that weird, like, oh, excuse me, they're trying to find their seat. That's kind of what it looks like trying to get to this test. Is you have to step through the function, through the switch case, into that specific switch case to test it. And so not only is this really, really hard to test, but it is impossible to reuse this code anywhere else. So what happens if you need to add another widget to your collection? Well, you have to essentially rewrite that code or find some other way to call it. And so just to summarize, hidden state, violating the SRP, and nested logic. I would say anecdotally that 80% of the problems that I see in code when I'm on client engagements stem from these 3 violations. Is that at the end of the day, it's nested state or hidden state, nested logic, and SRP violations. Now, this is what is fascinating about this. These are the easiest problems to fix. And so the most egregious violators of code quality, and yet they're the easiest problems to fix. And so not to leave you out on a cliffhanger, extract to parameter and extract to method. So let's look at extract to parameter. So I'm going to skip through a couple slides here. Those should have been taken out. And what we can do here is, instead of relying on something that exists outside of the function, all we do is we just pass it in. So if you have hidden state in your function, extract it to a parameter. So this is just dependency injection. And now your method is no longer dependent on hidden state because you're providing that state at any given time to that function. So extract to parameter. The next one, extract to method. So from here, you take these pieces of nested logic and you simply pull them out into standalone functions. And with an SRP violation, guess what? It's the same exact answer. You extract this to a standalone function that you can call. And so what this does is it now produces a bunch of fine-grained code that's very, very easy to test. And then you produce what I would call air traffic control methods that their primary job is to delegate, or to say, you land over here, and this is where you need to go. And from there, what you test is in this case, update courses, is this delegating properly? And if somebody calls on course updated, is this method calling updated courses properly and update total cost properly? And so this now segments your code into one set of top level functions that are simply responsible to delegate to lower level functions. And so you need to test that delegation logic. And then you have a bunch of smaller methods that are responsible for actually performing units of work that are fine-grained, single purpose, typically immutable functions that they do one thing, and you can call them the same way 1,000 times, and you will always get the same result. And so I'm going to hop into that stack blitz. And if you want to follow along, then by all means, please do. And we're going to fix this. So I'm going to just what I talked about, just so that we can see what it looks like. I'll go ahead and do that. And real quick, in the chat, I suppose, or Ashley, if you want to give me a thumbs up, if this code is legible, or if I need to make it bigger, let me know. You know what? I think I will make it bigger just because I think I can. So let me see here. Font. Yeah, I'm going to make this bigger. Hang on. I think everybody deserves at least a 24-point font here. Oops. There we go. And then we'll give this. I think that's funny that I changed that in real time. All right. Now let's go back. And I always used to be just so afraid of live coding because I was afraid I was going to die. But for everybody here tonight, I'm just getting over that. All right. So let's go ahead and let's just step through this. And we're going to just build this out. And so the first thing that we're going to do is we're going to extract this. This is immediately, when it comes to state management, this is the hardest thing about programming, and this is where things go completely off the rails. So from here, I'm just going to pass in mode. And boom, one of the dictators from the axis of evil is gone, banished. And then what I'm going to do is I'm going to create some smaller methods. So let's just go with delete. And this is going to take widgets and widget. And from here, we're just going to return this right here. So I'm not doing anything too fancy other than I'm passing in the collection and then the widget I want to remove. Now what I can do is I can go return this delete widgets widget. And you can see here, oh, it doesn't like this. So I need to pass in one more parameter. And I'm going to go ahead and type this. So this is going to be a little bit arbitrary what I type and what I do not, but just so I can communicate intent here. And let's do the same thing for update. So all I'm doing here is I'm just going through and I'm just chopping out these methods, or I think the official word is extract. And there we go. And this is going to be widgets. So again, live coding. I'm operating under the assumption that I'm not going to die doing this. So we'll do create widgets, widget, and we'll go here. And we're doing something a little interesting here. And because this is an example, all I'm doing here is I'm just creating a ID. So I'm simulating a database transaction here. Okay. And now I'm going to return widgets, basically essentially a new array with this widget in here. And so let's update these switch cases. Update widgets, widget. And I've done this one as well. Create widgets, widget. And we'll call this update courses. And from here, we got this pesky little thing here. Guess what I'm going to do? It starts with an E, ends in tract, extract. So we'll do one more here, which is, what did I call this? I think it's maybe update price, or I called it something. Oh, update total cost. And This is going to take in courses. Or not courses, widgets, silly me. And all this is going to do is just return. You're going to pass in widgets. It's going to add all the prices together. Boom, done. And then at the top, and so we've basically broken this all out. And now let's put it back together in a way that we can now essentially make this functional. So on course updated, and we pass in a course and a mode. And from here, we can just say this courses equals this updated courses, and this courses course and mode. One more for the road. And I keep saying course. You'll have to forgive me. Like I keep switching between widget and course. So let me fix this real quick because I've used this example both ways. Widget. I feel like everybody's probably texting at me like, bro, you're confused. So, and this is why I love TypeScript. Widgets. We'll go here. There we go. If anybody sees courses, just yell it out. And there we go. All right, we're getting closer. Let me change this to total cost. There we go. And we are almost done here. Equals this update, total cost. And I really want to type in course, and I'm not going to do it. I'm going to pass in this dot widgets. And I'm getting closer. All right. There we did it. And so now what we've done is we've extracted this out where I have 4 methods that I can test. Peer input output that I'm going to send you an array. This is one I want to delete, and then I can test the result. Hey, this thing should not be in here. And then I have 2 more methods that I simply need to test. Does this delegate appropriately? So not to veer off into a testing course, but I would say when I call update widgets with the create mode, does it actually call create with these 2 parameters? And that's how you would test that. So with that said, let's jump back into our code and continue on this narrative. And so what this allows us to do is now have fine-grained code as opposed to coarse-grained code. And so when we talk about complexity and abstraction and accelerated development at a very local level, we are essentially taking and we're managing that complexity. We're reducing that complexity. We're abstracting complexity into small, fine-grained pieces of code. And so we're moving from this, where this is actually a coarse-grained piece of code that's doing more than one thing, into a bunch of smaller stand-alone methods to where you could pick up update total cost, create course, update course, delete course, and really use that anywhere. Now, ultimately, as you start to develop your applications, and my examples will be in Angular, but a lot of this applies to really any framework that you're using, that when you're writing an application and your code starts to look like this, where notice these methods are single lines of code in them. Like all I'm doing is delegating to something else further up the application stream. This is a very easy class, or in this case, it is a service. It's very easy to work with. It's very easy to test. and it's very easy to extend. And so you want to move away from this code here. Again, the answer is extract the function, extract a parameter into this, and then ultimately in your real code on your real projects, whether you're using Vue, React, or Angular, is that you want your code, even if you're in Node or anything, is that you should have small, fine-grained functions that do one thing, that are going to return the same result every single time, or do the same exact thing every single time. And so 2 books that I like very, very well, or I think have been extremely helpful, is Clean Code, which is probably one of my favorite books on programming. I happen to have a signed copy of this from Robert C. Martin. And if my office ever caught on fire, this would probably be one of 3 things I would run in and try to save. The other one is a dolly, like a moving dolly, and my Red Bull machine that I got on OfferUp. So now you know what my 2 most prized possessions are. It's true. I have a Red Bull vending machine and I love it very much. But neither here nor there, these 2 books, Clean Code and Refactoring, are excellent. I highly recommend them. And so I would say add that to your reading list. So I want to pause here just for a second. Ashley, I didn't know if you wanted to do like Q&A or kind of pause for questions, or kind of what the format is, or how you wanted to handle this.
Yeah, that's definitely up to you. We can go ahead and use the raise hand feature. Folks can go onto the side of your screen. You should see a raise hand, and then Lucas, feel free to just call on folks.
Yeah, let me just see here. All right, I'm seeing a few. So I don't know how this works, so I'm just clicking buttons.
I think Chris and Thomas have some questions, and Lucas, I think on your screen, you should be able to see that as well and lower their hands.
All right, so, oops, oh no, I hit an extra button. So please raise your hands again. I'm messing this up. All right. So Thomas, you're up. I've just lowered your hand. Chris, you're up next. So we got a queue here.
Yeah, so thanks for the talk, by the way. It's been really fantastic and interesting. And my question is, so essentially, fundamentally what you're saying is almost 80% of the trouble that we create is by not following these very simple and basic rules. So why do you think, as developers, we have such trouble actually applying these such fundamental and such simple rules? Why do we struggle to do something that is seemingly quite basic?
That is a good question. And I think as with anything, that when you're trying to learn something, at least for me, is you're trying to like apply or to add things to your worldview to try to make sense of it. And so as you start to progress as an engineer, or as with anything, you're constantly adding information to allow you to do pattern recognition better. Because I believe that really the fundamental marker of intelligence is our ability to do pattern recognition. And so for me, a natural arc that I saw was I kept building and building, and I kept trying to learn, like, oh, I need to learn object-oriented programming so that I can have the tools to express the world around me. I need to learn functional programming so I can have the tools to learn to express this aspect of it. And so it's very much like building a vocabulary. And so, if you talk to somebody who's very good at music, is that they'll spend all this time learning an instrument, but then at some point they start to reduce everything into these simple concepts that they really can use across all instruments. And so if like Jacob Collier, who is a phenomenal like musician, and you listen to him talk, and he actually, I believe Wired is doing this thing where they try to explain these concepts at like 5 different levels, like to a child, to a grade school or whatever. And Jacob Collier is a master at explaining fundamentals or harmonic concepts in very simplistic terms, because he's basically reduced everything into these patterns. And so when I say this is an axis of evil, it's three things I see over and over and over. Well, I had to see that over and over and over before I could recognize it. When I program, I'm doing four things: nouns, verbs, conditions, and iterators. I had to do that for years and years and years for me to go and reduce that to like, I'm just doing four things. There's a really good book on cooking. And at the same time, I came up with kind of this nouns, verbs, conditions, iterators, salt, fat, acid, and heat came out. And it's just a phenomenal book. And so I think that you have to be exposed to a kind of a large data set to reduce and understand those patterns. The benefit is that now you get a benefit from 20 years of me kind of, slogging along and saying like, look, I think I can help shave a couple years off your career path. And these are the patterns that I'm seeing. And hopefully you can see them and apply them to it. So this is really what I hope, is that in a way, it's kind of me making myself ultra vulnerable and saying like, when I program, everything I'm doing, I can write on a single piece of paper. And it's really these three things I see over and over, kind of these four things that I see. And if I can kind of direct you and focus your attention on kind of these patterns that are going to really help you, I will feel like I've really accomplished a huge deal. So with that said, Chris, so patiently just sitting there, I'm ready. What do you got for me?
Excellent. Thank you so much for doing this talk and for the information. I think this is pretty enlightening. One thing that I think applies to me and potentially other people is that some of these nested or bloated functions or functionality don't necessarily happen overnight, but might take time.
Right.
And building on themselves and becoming bloated after adding on functionality over time. And so my question is, how should we think about long-term sustainability or of cleanliness of code if we have something or a function that we want to write that's fairly simple in the early goings, but we don't want to necessarily break things out into a bunch of cases that we're not going to need in the short term, but wind up needing them later in the long term. Is that something that we should be preparing for ahead of time? The potential to need to break things out, or should there be like a logical inflection point where we should consider how to, go about unnesting our code later?
So super amazing question. I love it. I love it. I love it. And so what I've just kind of shown you here is this is what happens when you stumble across some code and it's like, ooh, like I could make this better. Like, do not be afraid to refactor the method or to a parameter or whatever. At the same time, you don't want to prematurely optimize your code in the sense of like, don't create abstractions that don't exist for where you are at that point. And so the solution to that is, and this is why I show this example right from the beginning, is because that when you give new developers the tools to fix bad code, if you will, that it's like, look, if you run into this or you write this, you can fix it. And so I operate from this principle of refactor through promotion. And so it's okay to say, I'm going to put this thing here for now, but scale and time and new information changes those parameters. And so there's nothing wrong with, going and saying, from here, I'm just going to create a new thing. And we need to just see, first of all, we need to validate that this works. And so what I could do here is just like a reset. I'm just going to return an empty array or whatever. Well, maybe I realized like this, I actually need this somewhere else. And so this is not optimal over a long period of time, But what I do is I'm just going to refactor this. So just reset widgets, etc. And so this doesn't exist, but you now have the ability to say, I can extract this out and promote it to something else. More importantly, is that what happens if I'm like, I actually need this to be in a service instead of like a component? Well, then you create that service and you move this there. And so you're constantly moving things to these higher abstractions. So this is where's my complexity? How do I extract it, abstract it, and then move it to the appropriate place? And so I never abstract something until I need it somewhere else, until that I have essentially two consumers on a certain level of complexity. And then what I do is I abstract that to just the level one step higher than where those interested parties exist. And so you have to be confident and you have to say, first and foremost, so I believe it's Ken Block said, make it work, make it right, make it fast. And I think people get so hung up on, oh, I need to make this right and I need to make it fast. Well, at the end of the day, let's be pragmatist. Let's write good code. Let's not deviate off of first principles. But first and foremost, we need to make sure it works. And then we have to be confident in our ability to refactor. And so this is where, when I talk about abstraction and complexity, that not only are you writing good code, but if you come across code that needs, so it's not even bad code, it's just code that's no longer appropriate for the context in which you're in, which happens all the time. Oh, we've got this new information from a stakeholder. This is really what we need to do. Functionality changes, and you need to refactor and be able to refactor for that. And so this is a very simple example that I like to show, is that like, here's two incredibly useful techniques for managing complexity at a local level. And it really comes down to extraction. So hopefully that made sense.
It did. Thank you.
Awesome. All right. So now let's move on to part 2 of this journey. So this is a 3-stage act, and we're going to part 2. Now, I don't know if anybody was here the last time I presented. I'm thinking probably not, but we're going to do just a really quick review of what we did, just because it's relevant for this next part. So I talked about the 4 elements of programming, and we talked about nouns, verbs, conditions, and iterators. And we started out with some really, really simple code. And we created some objects. We did some data modeling. And then we talked about verbs and how to make these objects do things. And from there, we talked about conditions and iterators. And ultimately, what we ended up writing was Redux from the ground up. So over the course of a couple hours, we wrote Redux, and we had a reducer and we had a store. And it was kind of at the end, like, ta-da, magic trick. And so that's where that whole Karate Kid reference thing came in. And it's like, we're just building on these principles. And all of a sudden we went from the most basic things, nouns, verbs, conditions, iterators, into what I feel is one of the most relevant state management patterns that exist for front-end developers. And so I'm just going to leave this here as a reference point, that this code here that we wrote over the course of a couple hours, it's incredibly simple, that this allows us to do some really interesting things. And so I want to talk about application complexity. And we're going to take a journey through space and time. And I'm going to talk about how this relates to the work that you're doing now. So let's start at the beginning. So the code for this, real quick, if you want to check it out, is at this URL. Oh, real quick as well, I'll actually pull this out, export it as a PDF, and I'll send it over to Ashley, and she can post it. So there's actually a bunch of stuff at the bottom of this slide deck that is like, here's some thoughts that may be helpful that I'm not going to talk about. So everybody will get the PDF if they want to reference it. So I put a bunch of extra stuff in there per chance it may be useful. So start at the beginning. So I don't know if any of us have ever tried to build I'm using air quotes, a jQuery application. They don't really exist, but we tried our best. And the thing with jQuery applications is that it was really all about the DOM. And maybe you've heard of this term, the single source of truth. Well, the DOM was the single source of truth. State was in the DOM, and we used jQuery to manipulate it. And so this was super cool back in the day, but there was only so much we could do because DOM is static. And so then along came jQuery or AngularJS, and this is a classic AngularJS application. And we suddenly had the ability to separate declarative markup and imperative logic in a template and a controller. And so we were able to decouple that business logic from the DOM and put it into a controller. And so the controller became the single source of truth. This was a huge deal when this happened. And from there, our applications quickly grew and they became more complex. So in my case, I'm like, this is amazing. I really would like to do this and make money. And so I immediately went to my company and said, hey, this is great. And they said, you're on. And things started to grow. And we often needed to pass information between these controllers. And this is where things get tricky. So how we solve this is we would create a shared service where the single of truth would live. And so notice we're now moving further and further away from the DOM. And this was fine, except that our applications continued to grow and we began to have many services. And the single source of truth wasn't so single anymore. And like, it was cool because like, we're just putting out all this awesome functionality and features, but it started to get really confusing. And this is where I began to kind of have a problem, is that it was very, very common to have a service that would communicate with the remote server and at the same time manage that state. And so if somebody said, just apply this, what does this server do? What does this service do? Well, it calls the server and it manages state. Single responsibility, principal violation. And it really bothered me that this is what everybody was doing. And so along came Redux. And this solved the solution, or this presented a very viable solution. And it allowed us to split our logic or peel it away from the state management piece. And so now we had our logic in the reducers, and then the state management went into the application store. And so the store became the single source of truth. And this pattern that you're seeing here, what you'll see from a very visual standpoint is that the single source of truth is moving further and further away from the component layer. And the components are becoming thinner and thinner and thinner. So just kind of zoom through here, DOM controller service, DOM controller stateful services, plural. And then you have Redux, which then now you have DOM, components or controllers, reducers, and then state, which is becoming that single source of truth. What I would say is that we're continuing to promote the complexity to higher and higher levels of abstraction. So even visually, we're starting to reinforce this idea. And so what does this have to do with space and time? Well, I want to share a quote with you. And I just happened to be, as I was thinking about this, I was reading this book, The Theoretical Minimum by Leonard Susskind. And he made this statement: in classical physics, if you know everything about a system at some instance of time, and you also know the equations that govern how the system changes, then you can predict the future. That's what we mean when we say that the classical laws of physics, physics are deterministic. And if we can say the same thing, but with the past and future reversed, the same equations tell you everything about the past. Such a system is called reversible. And this really jumped out at me. I mean, I almost just I almost fell out of my chair, proverbial speaking, is because in one statement, in talking about classical physics, classical Newtonian physics, he essentially hit on everything that I believe about well-architected applications. Like, this is what software should be. Now, I imagine I can only see some of you in the chat room, but I feel like I'm getting some incredulous stares, but I feel like some of us are just like, what? And so let's step through this. Let me unpack this so I don't leave you out in this beaker state here. In classical physics, if you know everything about a system at some instance of time, well, in a system, we know everything about it at any given time because we have the store. All our state is in one place. And you also know the equations that govern how the system changes. Well, where are all the equations that govern how our application changes? Well, in our reducers. And then you can predict the future. That's what we mean when we say the classical laws of physics are deterministic. And because reducers are pure methods performing immutable operations, it gives us referential transparency that gives us a starting point that if we sequence steps through the reducers, we can accurately calculate the future state of that application every single time. And so going back to that first module, when I really keyed on, I can call this 1,000 times and I never know what I'm going to get. Well, now that you know what you're going to get, you can then predict the future state of your application. This is why this first module was so important to the second module, or the second act of this. Conversely, if we can say the same thing, but with the past and future reversed, it's essentially called reversible. And so with Redux, you can absolutely do this, is that not only can you predict the future, but you can take any specific slice of time from a point in state and then reverse time and recalculate historical state. And this is really, really powerful for a lot of reasons. And so to understand how this works, let's start with user input and response. And so again, we're talking about complexity and abstraction. So typically, we think of interactions in this sense, that a user generates an event, and then we immediately fire some logic into the event handler. So you click, event handler, event handler. This relationship restricts what we can do because it binds us to a very specific window of time and space. But we can separate the event and the handler by using, drumroll, actions. And so now, instead of thinking of user events as event response, think of user events as event dispatch, and then response. So essentially, we're using the observer pattern to decouple events from responses. Conversely, we can have a stopping point represented by state at a moment of time. And if we know the sequence of actions that led up to that state, we can reverse time and recreate that historical state. So from here, we can use this mechanism to play with space because we can bypass the DOM entirely and produce that corresponding action somewhere else. And we can also use this to play with time. because you can withhold or suppress that action and then emit it at some other point. And so this is what I'm proposing, is that when we redefine how we think about interactions, we can change how an application experiences time and space. And you can notice here that all the interesting things that we're doing is actually outside of the component, because we're abstracting out that immediate event handling and moving it elsewhere. So let me show you a couple of real examples to really kind of dial this in, because I even see Ronnie's like, this is philosophical. And I agree. If I stopped here, it would be very theoretical. And so let's anchor this in some code and some examples. And let's start to just incrementally step, or build this in a way that we're going to lead to a conclusion that I think will be gratifying. So let's start with space and just a manual dispatch. So we have a click, we capture it, and we convert it into an action. Well, what we can do from the upside down is we can actually inject that same action. And so if we have an array of action objects, we could manually step through them one by one and dispatch them into the application. So I'm going to pause the slideshow for just a second, and let's see what this looks like. So if you pulled down the application and you ran it, this is what you have, is you have this manual step. And what I want to show you here is that you can see here that I'm clicking and it's selecting this current client and it's showing it over here. Okay. Well, now I have these actions here, and I'm going to click step, and it's going to manually dispatch that action. That if I click this, it would create an action. I've recreated over here. And so now notice, pay attention to the right-hand side as I step through this, that I'm able to recreate the physical interactions of me clicking on the clients in the list. And instead, I'm able to, over here, create a little bit of distance and now dispatch this action. So kind of interesting in the sense that I'm recreating a human interaction by sideloading an action into this particular application. Now, let's go back to the slides and let's build upon this. So now we've introduced space, that I'm clicking over here and it's selecting things over here. Well, now what we can do is, if one user interaction is an action and multiple user interactions is a user flow, that I can capture those and recreate a particular user flow. And if I have those actions, I can cycle through them. And so now what I'm doing is I have that same array of actions and I'm able to step through them as well as play with time. So now I can go into manual cycle, and if I click this and I click cycle, then notice now my hands are completely off the board, and all it's doing is just replaying these actions over here. And so now I'm starting to play with time and space. And I can make this like super slow or actually super fast. I'm presuming there's probably a bug in the code. Hey, that happens. But notice that the time has significantly shifted to where before it was slow. I wonder if this is like reversed. I feel like, oh, somebody's trolling me. But if I go here, well, that's super fast. So no, now I'm playing with time and space. How am I doing this? All I've done is I've simply created some separation between a user interaction and or user event in the action that I dispatch. So let's take this even further. What if I could pull in an action from anywhere? Like just download something off the internet or download this from an API and then play it. And so instead of hard coding these in like this, what if I could essentially load them from a remote source and pull them in? So, you know what? You just walked into my trap, oldest trick in the book, because guess what? We can. And in this case, imagine we're pulling from an action service and saying like, hey, give me an action. And I want to do something with it. So then you pull in an action from a service and you dispatch it. So let's see what this looks like. What I have here is I'm going to just walk out on a limb. I feel like localhost. Oh, wait. This is going to be, I'm just guessing here. Yes, somebody's requesting I increase the browser font. Give me 1 second here. I feel like I should know where Nest is. 1 second. I've totally forgotten that port. Let me just spin this up again. Wait for it. There it is. Triple threes. All right. So let's go back to the browser. And I'm going to paste this in just so that we can see what we have here. There we go. And so this is an action. So hopefully, Sherry, you can see this. I'm sending all of my best wishes your way. And then I also have an array. So we're going to see this in the next example. But from here, we will, let me dial this down just a bit. Let me go to dynamic step, fetch. And so I'm pulling this in off of this API over here. So this is coming from a remote API. And then I'm able to dispatch. What I could do is I could go create. And I think if I go null, and let's just go holla at, this may or may not work. This is always the joy of doing this, that I'm dynamically creating an action by hand, and there we have it. So DJ holla at your boy is now in the house, and if I put this into the API, I can load it in. You know what I'm going to do? Enough playing around. I think you know where I'm going with this. So I can pull in an entire array of actions off of this API. So here, and make that work. I'm going to do something real quick because I'm inspired. Let's go create again. I'm just going to throw one more mix in there. We're going to call this guy, oh yeah. Company Tiny Diamond, which is my nickname for my 5-year-old son. And now let's dispatch. Let's see what happens. I really hope this works. I do need to make this a bit smaller. All right. Oh, yeah. So now we're able to step through a series of events. And notice I haven't touched anything over here. It's all been happening in this left-hand side. So time and space. How have I accomplished this? By abstracting complexity away from the component layer and moving it somewhere else. Thanks, Redux. And so I have a request for some example use cases, which I will happily oblige in just a second. Let me make sure. I got 2 more examples. I'm not going to demonstrate. I'm just going to talk about that using something like Firebase that, or like a GraphQL subscription, is what if you took and you used something based on a WebSocket like Firebase or GraphQL to dispatch those actions across the universe. Well, now what you can do is create something that looks like this. Is that you now have something like a real-time database, such as Firebase, that is now using WebSockets to communicate this action dispatch and send it to multiple connected clients. And another thing that you can do is something like undo and redo. So you can have a meta reducer to where you can say, I want you to play this action, or I want you to undo this action or redo this action. And now by playing these actions forward, you can play them backwards and recreate state. And so now this is for my buddy Winston. What does this mean? Well, we talked a lot about science and fancy sounding philosophical stuff, but like, how does this translate into something that we can actually use in our real job, AKA show me the money, man? And so let me give you a couple examples of how you can use this, or even how I've used it. So one, QA. And so this allows for an automation layer that allows you to simulate user interactions without a person having to sit and manually click. Like, never, ever let a human being do what a robot can do perfectly every single time. And so automated testing, bingo, boom. This is pretty much, I've just given you a money printer. Real-time support. So you can use this remote dispatch cycle to sync client state for a user that might be having a problem. So I don't know if anybody's ever used like VS Code Share or something, but like this is an example where you're syncing state across space and time so that 2 people can collaborate and essentially share state and work on the same thing over and over. So remote support is that essentially imagine a scenario where somebody's saying, I really don't know what I'm doing here. And they're able to transfer their single state store, their application store, into a place that you can then access it. And you can start to manipulate that. And you can basically walk them through how to solve that particular problem. So real-time support. A big one for me, automating repetitive tasks. Like, imagine doing something really, really tedious, like data entry, where you're doing the same thing over and over and over. Well, one of my friends, she was an administrative assistant. And one of the reasons she decided to become a developer is because she hated doing the same things over and over and over. Well, this, in a way, solves this problem. And I actually know one of my best friends is that he applied this approach and he reduced his 40-hour work week into about 20 minutes of macros. And so you can use this in a way that, imagine you have an application that you're doing the same things over and over, and somebody could press maybe like a record button and it would just capture those actions. And you could say, I want to create this array of actions. I want to give it a name. And I maybe want to change some parameters. And I want to be able to replay this over and over and over. Can you imagine writing an application that would give that level of power to where you could actually create higher level tasks to automate lower level tasks? Like, what kind of value would that provide to your user base, where they're no longer having to do the same things over and over and over. So those are 3 off the top of my head. I feel like any variation of this is extremely valuable. And so now let's do the grand finale for this. We are grand finale, second act, and I want to talk about the thin component. And so we've been talking about space and time, and we've also, obviously, I've talked about Redux quite a bit. And this is what makes this possible. But I haven't been super forthright with how we're implementing Redux in our application. So we're using a simplified version of Redux. This is what we saw at the beginning couple slides. So this should look familiar, familiar, familiar. And like in the code, we're just consuming it just like every other piece of Redux. And this is the store. But here is the interesting twist. This is the M. Night Shyamalan twist, if this was a movie, that this store is not in the Angular application at all. I've actually put it into Socket.io, and I'm consuming it in a Socket service. And so other than some like demo stuff, this application is completely stateless. So, okay, what does this mean? Well, thank you for asking. I welcome the opportunity to explain what is happening here. So, because Redux is in Node and not in the Angular application, I can do something like this. Notice I'm over here on the left-hand side, and I'm like, oh, we need to get, oh yeah, out of here. He's not welcome at the party anymore. How did that happen? You know what? We got a real name policy here. This guy's real name is Jonathan. If I spelled that wrong, I apologize. Smitherson, whatever. And notice when I save this, I'm on the left-hand side and it saves on the right-hand side. How am I doing this? Smitherson, this, and actually he works at QT, which if you're in the Southwest, maybe they have them in California, but it's a pretty reliable chain of convenience stores. I quite like it. Save it. And so now I think we get the point here is that if I do something on this side, it happens over here. How this is working is if we go into our code and you look at the server, this is almost exactly word for word, line for line, the version of Redux that we wrote at the previous Hangout Jamboree that we had. Nouns, verbs, conditions, iterators. This is the reducer. Notice all this is doing is delegating. And I've just put this into Socket.io, which means now we have an application that's very, very thin. So when we talk about complexity and abstraction, now we have the ability to write applications that are clients. In this case, it's very, very thin. Notice it's not doing much. Let's look at our template. So I'm going to just step through, and you can see here that the templates are very thin, that this component right here actually has no units of logic. And this one has a little bit of logic only because I'm taking shared mutable state and then breaking it apart into just mutable state, and then I will reshare it back up. And so for this example, we've talked about local complexity, and then we started talking about application complexity with this goal of accomplishing this particular piece right here. But we're taking it even a step further. Is notice now we're abstracting out our complexity further and further and further away from our components, which allows us then to have a better distribution of effort where our components are very thin, they're reusable, they're very, very light, and all of our complexity is now being moved away from that into what I call the business layer, which has really state and data and the logic around that. So I would say this concludes act number 2, or the second movie in the trilogy. I promise not to break my third movie into 2 movies for money alone, but I want to just stop for a second and open the floor up for questions. And so what does everybody think? Do they have any questions? How do they feel about what I've just showed them? Is it making sense? Are we still friends? I'm desperate for your approval. I'm just kidding. No, I am. Maybe I'm not. We'll see. But with that said, if you have any questions or you have a question, like raise those hands and let's chat about this. All right. I approve. Excellent. I feel like 2 out of 2 reviews. I should just be like, and we're done here. All right, Chris, I love it. Hit me. What do you got? Wait for it. I'm trying to see if I can unmute you from my side. I'm just going to keep pressing buttons. There we go.
There we go. Yeah.
Yeah.
Sorry, couldn't unmute myself for whatever reason. So just to see if I'm understanding correctly, or maybe get a bit of a clarification, you are basically moving the state. Is it coming from the store into Socket.io, or is like, how are the store and Socket.io linked in the example that you just showed us?
Very good question. So if you look at my screen, that we have, I do have the meta reducer in here, which I didn't talk about, but I'm instantiating the store on line 201 here at the bottom. And then, and I'm not for sure why, I feel like I should probably put like Socket.io like way at the bottom. So I'm creating the store, and then from here, I am essentially, all I'm doing is hooking up some events to it. So I'm saying when it connects, that I just want to wire up these event handlers, and that's that. So the Socket.io piece in the server is what's 18 minus, like it's 12 lines of code. Like, that is pretty awesome.
I see. Very cool.
And then let me, what do I call this? And then from here, the socket service is less than 30 lines of code. So on dispatch, instead of sending it into like a local version of Redux, I'm saying this socket.emit dispatch action. And so I'm listening as well for when something happens. I got very, like just a little bit of handling here on this. So Socket.io, that code is like 12 lines. And then I have a service that is less than 30 lines. And this is it. And so again, kind of, I just feel like I'm always pushing everything down to like the simplest possible forms and finding the most clever things that we can do with this, is because when you really understand these basic principles, you can start to put things together that appear to be, and in fact, they are absolutely like professional, high quality, enterprise grade applications. And so that's where it is. And so I would definitely say, check this out, pull it down. If anybody runs into a question or whatever, like, you can catch me on Twitter. I accept DMs. I do like to eat and sleep and spend time with my family. So I try to be as responsive as possible, but that's where that's happening. So hopefully that was helpful. Like, check out the code. If you get stuck, we can have another conversation. I thought Thomas had a question. Oh, yeah. I got a question for Thomas, and that is, where do I get those cool Tron glasses?
You have to get them from Amazon. Actually, that are actually laser-proof industrial grade glasses.
Oh,
These.
so in case you have to go welding after this, like, I imagine you're in the back welding a bumper onto a car.
They double for welding, so it's multi-purpose.
That's awesome. All right. What's the question, my friend?
So I got to be honest, this is stretching my understanding a bit. So I don't know if
Good.
I'm
That's all right. You're getting your money's worth. If not, I'll give you a refund.
Yeah. So we're extracting out our store and our reducers and our logic further and further away from the DOM, right? And this seems to have been an ongoing process as the front end is developed through time. Where is this leading? If this surely isn't the limit of how far this can go. If you take this idea all the way to like its extreme or its endpoint, where is it taking us? Does that make sense?
So I don't have that answer, because I think there's infinite permutations of this, but I will show you in the last chapter. I'm actually going to give you, everyone here, a preview of what I'm going to be presenting at NG Enterprise this week. So you are actually, outside of a few people, are going to see something that I invented that I feel is a pretty interesting extension of that. So for me, I think that the extension of this is large scale distributed computing in the cloud. That's for me personally, that's where I see it going, is that with minimal effort, you're able to express ideas in a way that can be translated and conveyed into the cloud. And so once I get to this last act, I'm actually going to do kind of an outro, credits roll, and then, basically like Samuel Jackson walks back in as Nick Fury and he says something really cool. Like, I'm actually going to just offer a little bit of commentary around domain-driven development and how that you can really accelerate that. But the idea is that I believe by starting at these very simple basic principles and building on it, that in really keying in on time and space, where I really want their mind to go, is we can take these ideas and we can apply them at scale in the cloud. Like, there's no reason you couldn't pick up this reducer and put it into a Lambda function. Or there's so many ways. Like, I mean, I would love to find out where these limits are. Like, this is one of the reasons why I'm so excited to share these ideas with, new programmers and people that are excited as I am, because I would love for each and every one of you to, be laying at bed, in your mansion in Beverly Hills with your snakeskin rug, just staring at the ceiling. And all of a sudden the next $1 billion idea pops in your head as a result of that. And you realize, like, I can't be a rapper anymore. I'm going to go be a tech billionaire. And that's what you go do. And so I make it a little bit facetious, but I mean, that's the idea, is like, I'm throwing these principles out to say, like, here are some really good building blocks. Apply them in ways that I haven't even considered. All right. So hopefully that was helpful.
Yeah, no, thank you. That was really amazing. And it's been an incredible talk. So just
All
thank you for
right.
your time again.
Well, I feel like I could just then, like, maybe retire like Derek Jeter and be like, I don't need to finish this third act. I'm just going to quit while I'm ahead. Kidding. I'm not going to do that. So I'm going to show you something. I'm hoping if this gets published, it's after this week, so that because this actually nobody's seen this until really tonight, which means I hope that it doesn't explode and I embarrass myself and ruin my career in one fell swoop. But all right. So I'm going to close this one down. We no longer need it. And I'm going to show you an extension of this that, so we're taking something very, very simple and I'm fanning it out as far as I can. And I'm going to bring it back down with a little bit of commentary around domain-driven development at the end of this. So looking for my slides. All right. And I'm going to share my screen. Let's talk about enterprise complexity, which I was going to make a joke, but it may not age well, that enterprise complexity is just the, it's just really larger amounts of, it's really dysfunction at scale when I think of enterprise software. So there we have it. The code for this, you can check it out here. That's true. If it's recorded, it's not a secret. I'm just hoping that it stays a secret at least for 2, maybe 3 more days. If not, no big deal. I mean, I didn't really sign an NDA or anything. So, but I really wanted to share this with you because I'm super excited about this. So it's not going to murder me. Awesome. Yeah. Catherine pasted it in. Thank you so much. All right. So let's get enterprisey. So every application, it starts as an idea. And from this point of inception, that there's really no turning back, that we add features, functional enhancements, things happen, and the application grows in complexity. And it continues to increase in complexity until we arrive at the enterprise stage. And so with enterprise software, you're really dealing with organization complexity to where you have the application you're working on, which is segmented by lines of business with their own set of KPIs that they need to meet. And at the same time, they have this same basic need for self-preservation. And so everybody wants something different. Everybody needs to stay alive. And this leads to a very awkward kind of dance is everybody tries to coordinate a release at scale. And what this looks like is a bunch of stakeholders standing around watching an application being deployed, and they're saying, I wonder why this isn't going better. And I've just experienced this more times than I would like to admit. Unfortunately, this is really not super funny when it happens, because usually what this means is you're going to be up until like 2 a.m. because one thing is not playing with the other thing. And so a really viable solution for this, and I believe it's a game changer, is module federation. And so I'm not going to talk about this at a molecular level. There's a lot of, it's pretty new, but Manfred Stayer, who I call him my Manfred, he's done some really, really good posts on how to put this together. So I defer to his genius. What I want to talk about is some concepts around this to really start a chain of thought, to plant that idea, as we talk about inception, that I think can ultimately, blossom into something really interesting. So just to set the stage, that we have organization complexity, and what we do is we extract those units of complexity into standalone, self-contained modules that can be independently developed. More importantly, they can be independently consumed. And so my goal is to present a couple patterns that somebody could use when they're adopting federated modules to really, I would say, create or maximize their options and reduce future pain by adopting some of these things. And a lot of the parameters that I use when I think about federated modules is it comes from microservices. And so if you want to look for at least a pre-existing paradigm for federated modules, is that I would start with microservices. And so imagine that we have a large number of modules that are available to us. And so we have a dashboard, and we'll call this the consumer. And then we have N number of producers in the form of federated modules. Well, how do we signal that these modules are available? Well, how I would do this is I would create a central registry, and I would call it #ledger, trademarked, that allows us to register modules. And so now these two modules can essentially register themselves in the ledger, and then the consumer can say, hey, what modules are available to me? And the ledger can say, as it stands, I have 2 modules. And the consumer can say, great, I'll take them and load them in. And from there, you can register a new module, say, hey, consumer, I have this new module available. Do you want it? Register another one, make it available, and consume it. So module discovery is a very interesting pattern, because as you start to distribute your application across space and time, Thomas asking, where does this go? Well, scale presents a whole new set of challenges. Well, in this case, is when you have a widely distributed framework, how do you know it exists? That imagine you have a number of microservices that exist in containers, and you're spinning up containers and you're tearing them down. Well, how do you know what containers are available? How do you know what services are available? You take like Amazon, who is built on this entire premise of microservices, and how do you know what is there? Well, it's service discovery. And so having this ledger, if you will, that you can now say, hey, I'm going to register myself with the ledger so that anybody who's interested can consume me, or I'm making myself available for consumption. Now, another example of this is, or another extension of this is a health check. So not only do you need to know what modules are available, you need to know which modules are healthy. And imagine a black swan event where, for some inexplicable reason, all your code is working, and the universe catches you smiling, and it says, not so fast. And a lightning bolt comes down and a module goes offline. Well, because the ledger is monitoring all the hosted modules, we detect this almost immediately, which can then mark this module as offline and then communicate it to the consumer that this module is not healthy. You need to handle it. Here's another one, authorized consumption. So imagine you have a super money cash dollar consumer, and they've bought your highest enterprise plan. And so you can say, hey, you get all the modules. But then you have a restricted consumer. So this might be a startup. And they say, we only need these 2 modules. Well, what you can do is, based on their identity and how they authenticate with the ledger, you can say, these 2 modules are available to you, versus these 4 modules. But this is nothing more. So you hear me talk about nouns, verbs, conditions, and iterators. This is simply coming down to, if you're this type of a user, if you're this user, you get this, if you get this. So now we have a restricted consumer. A very similar variation of this is split testing. So imagine you have 2 variations of the same module that you want to split test across end consumers to see which one tests better. And so now we're getting kind of really practical here. This is something that I think organizations should be doing more of. Well, now you can split those module variations across multiple consumers. So you got the green on the right or the left, yellow on the right, or you can flip-flop it. And you can do this dynamically. And then here is my favorite one, module inception. And so this is essentially federated modules inside of federated modules. So my friend the other day, I was explaining this to him, and he's like, I've got a perfect example, a perfect use case. And he logged into Jira, and he saw that there was this VS Code start work in VS Code. And dun, 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 Winston gets the dramatic music, and he's looking, and he's like, wah, wah, wah. Why is this here? Like, nothing against Jira, certainly nothing against VS Code. I think it's great, but this is a cloud project. And he's like, why? Like, why is this here? Like, I didn't opt in for this. And so now you have a hard-coded and unwanted feature. This could have been solved by allowing for the dynamic composition of features using federated modules. And so what I imagine this would look like, dun, dun, dun. I don't know why Winston had to talk about dramatic music. Now I just want to sing talk for the entire rest of this presentation. I'm not going to do it. I'm not going to do it. I'm not going to do it. That you register, do it. I don't know. I just may. You register a dynamic module outlet into the ledger, which then gets consumed into the dashboard or the consumer. And from there, you can consume individual modules in any configuration inside of the module outlet. And so I don't know if you can see this, but like basically I'm switching the colors around. So before we ride off into the sunset, I want to show you what this looks like. And the thing about dynamic modules, or really federated modules, is every module is hosted. So I'm going to hop into this repository, and I'm going to, I need to create at least 4, and let me change this up. This isn't going to matter too much, but at least let me do this in a bigger font. And so from here, npm run serve primary. Secondary, npm run serve partner. And so I'm spinning up these submodules. As you can see, they're coming up. So we have client, which is, or rather not that one, but we have the primary federated module, secondary federated module. I expect at some point another one's going to show up. So this is a module inside of a module. It's turtles all the way down. And then from here, I can go npm run serve all. This is going to show up at any moment, and we will be able to continue. But what I want to point out here is notice that primary is served on 4200. So this is a standalone hosted module. Secondary, 4203. Partner is 4204. So now on 4204, what I'm doing is I'm loading this module, but then I'm also subloading this module over here. And then we have the dashboard and the ledger. So what I can do here is I'm going to go ahead and I'm going to delete this. All right. Now, did you notice here on the right-hand side, gone? Why? Because it's like this module doesn't exist anymore. It got taken out of the register and it went back. And so then from here, I'm going to go secondary. And this is where things go totally off the rails. This is where I need like a dial-a-friend to like, how do I do this? All right. So secondary, I think the URI is, if I'm not mistaken, 4303. Secondary component. So this is the component that's in the module. And we'll go secondary and, oh wait. I'm trying to do this from memory, which is wildly irresponsible. And secondary. And I'm going to publish this. So now save. And you can see here, it immediately showed up on the right-hand side. And I can say, hey, like, this is pretty cool. I want to make this available. And so now I'm immediately saying this module is available and I want to load it in my application. Load it. Yep. Load. Okay, fine. I'll leave it there. Now, this in itself, I think is interesting that I've just registered a module in the ledger and immediately the dashboard picked up on it. But let me go over to, which one is this? So this is secondary. And I feel like in order for this to even make sense, I'm going to go ahead and I'm just going to, I'm not serving this anymore. And you'll notice that this immediately was picked up and it's like, oh, like this isn't healthy. And now this is muted over here. So let me spin it up. Fine, I'll put it back. And when this spins up, what's going to happen is that you will see that this will, all of a sudden, it's healthy again. And so now in the ledger itself, we're able to detect and we're pinging, we're polling like, is this healthy, healthy, healthy? It's not healthy. You let your consumers know like this module that you're hosting, it's not healthy. You need to do something. And you can handle that however you want, but we're able to do service discovery, like module discovery and a health check. And so let me register one more. And I think this is pretty cool that we have. So imagine you have a partner that they want to essentially have their own kind of module outlet that from there they can determine, or they can say, we're going to allow you to host a module that you can then host other modules in. And so now this is, you get this framework conception where you can just go all the way down. And so from here, this is feature component and partner, and the module is feature. And I'm going to publish this, save it. You saw it happened right away. Boom, click. And now I'm loading a module that has a module being loaded inside of it. And so I think if you ask me like, how far can you take this? I would say distributed, applications, real time, in the cloud. And all that I'm doing is I'm taking these concepts that I talked at the beginning, extracting complexity, and just pushing it further and further and further away from the consumers into the point that we're able to dynamically consume modules that are dynamically consuming modules, and that you can come over here, and if something happens, that all of a sudden it gets picked up, that it's no longer healthy. You saw that now I shut down secondary. and it's saying, I'm not healthy. I'm going to disable myself. Imagine being able to communicate across space and time in that manner into your applications. And so this is what I've been working on. This is, for me, at least right now, I believe like this is where the future is that it's ultimately the ability to abstract your complexity out in such a way that time and space no longer matter. And you can dynamically compose things in really, really powerful and meaningful ways for your customers. So I'm going to pause here and I'm going to open the floor for questions. So don't be shy. Raise your hand. Oh, yes. All right. I think, where is that? Hold on. I saw somebody raise their hand and then I lost. I wonder if I need to. Oh, there we go. Tang. How's it going?
Hey, I'm well. How are you doing?
Good. What do you got for me?
Yeah, so I was curious about so in the like body text of the micro front end thing, it says that Angular is shared so the download is minimal for the front end. Yeah, how do you keep like how would you end up keeping Angular in sync across all of your like micro front end like modules?
So the answer is, like, technically you don't have to, which is also interesting. And so this is, I do not claim to be a super expert on this. So this is really, I think, made available by Webpack 5. So it's a little bit experimental. I would check out Manfred Steyer. So this individual, Manfred, is amazing. And I would check out his website. And he has some really good posts on this. He walks through a 5-part series. And one of the parts that he talks about is how do you handle version variations? And the answer is like, you don't technically have to do that if you don't want to. And so there's another version I have where I call it Framework Tetris. I don't recommend doing this. It actually, like, I started, I'm like, this would be really cool. And I'm like, this is a horrible idea, but I can do it. Where I'm loading React, Vue, Svelte, and Angular into a single page. And so, like, it can be done. I don't think it's practical, but this frees you up from actually having, like, you can actually do this without being dependent on versions. With that said, I would recommend it for really consumption reasons. And I think that you would just have to make that a requirement or find some way to enforce that in terms of, if you're going to, I would think of it as like an API. Like, if you're going to publish a module in the system, it needs to be on this version. And you just have to communicate, like, those are the parameters. So hopefully that made sense. This is a little bit experimental, but that's the idea.
Cool, yeah.
All right, next question. I know that there has to be at least one, maybe even two. Wait for it. All right. So let me offer some commentary real quick on domain-driven development. And I think this is going to bring this kind of back into full circle. That when I talk about programming and I talk about the 4 elements of programming, which is nouns, verbs, conditions, and iterators. More often than not, when I start talking about nouns and what this looks like, and it's not super fancy, is actually a lot of times I just go straight into like Sublime. Let me just open up a new window here. And so this is just, I'm showing you an insight. So this is imagine post-credits outro scene. I'm just giving you some insight into how I think. That let's pick any domain. Let me think of something. So I'm interested, like, let's pick a sport. Like, let's say like football. I think that's really the only sport that's happening right now. And you could say, like, I have a team. So the first thing I would start doing is I would define my interfaces, which is essentially you're defining the shape of your data structure. And so I would say I have an interface, and it has a name, and which is a string, and let's say it has a location, which might be a location. And so I'm freestyling here, but let's say it has a mascot, which is a string, and it has players, which is an array of players. All right. And then from here, I can say, okay, well, we have a player. And so I do this on every application I start. Like, this is where I start. And so when people roll their eyes around, like, oh, I can't believe I'm writing JavaScript objects, like, I want to learn the fun stuff, is that I believe one of the main reasons why applications go off the rails is because people don't actually understand or take the time or discipline to data model correctly. And so when you actually take the time to really think about your objects and the data model for that domain, that if you get it right, it's very easy to build off of that. If you get it wrong, it's very, very hard to fix, because if you mess up your data model and you build on top of it, essentially you have a crack in your foundation. What does that mean? Is you have to go back. So imagine you have this whole app, full stack app, database, server, web application with state management and a form, and you're like, oh, I needed this additional field. Guess what you have to do? You have to go back to the database, add that field in, then you have to go to your server, update your API, then you need to go to your application, update your state management, all the logic around it, update your interfaces, and then you have to go to your UI and update that. And so when you get your data modeling correct, and it does change, and I'll talk about that in a second, that it's going to save you a lot of time in the future. And so from here, I'm just going to put some properties in here. And let's say we have healthy, and this is a Boolean. And let's leave it at this. Now, if I showed you this interface, you should be able to infer a lot of things about this. From what does the form look like that allows you to actually input data into your application? Well, if you look at a player interface, it's like, oh, well, what are we going to have here? First name, last name, those are going to be strings. A position, that's going to be either a string or, in this case, it would be a string, it'd be a text field. So 3 text fields and a checkbox. And now imagine I wanted to add another one in. And so this changes a little bit, but I wanted to add in a bio. Well, this might be a long form. And so I would say this might have a text area. But when you understand the model, then you understand a lot of things about what the shape of your application is going to look like. I can tell you what your REST API is going to look like, and that's fairly simple. Like, your REST API is going to be exactly the same. Is that I'm just using kind of a local nest one here, is that I'll put this up here so we can see it. If you wanted to get all the players, this is what this is going to look like. REST is conventional. If you wanted to get more than one player or just a single player, if you wanted, so this would be get, this would be get. And so when you understand the domain, you understand how, or you can infer a lot of detail. So if I wanted to create a new player, if I wanted to update a player, I'm going to put to a specific record, and I'm going to pass this in on the payload or the payload. If I want to delete, then I'm just going to call it delete, and I'm going to pass in that ID. Now, this is where this gets interesting, and I'm taking the time to show this because I want us to start thinking about how this affects our local development. We have player here. What I can do now, and so in order for this to work a little better, I'm going to just say I pass in a player. All right. Now, let's say we introduce another model. Let's say I want to introduce stadiums. This is exactly how this would work. All I'm doing is I'm changing the model, and the shape stays exactly the same. And so if you go and you look at, for instance, an Angular application that has that's really fully reactive, it's communicating with the REST API, etc. Hopefully I got this right. Wait for it. Perfect. So now, if you look at core data, and I'm just pulling back the curtains a bit so that everybody can see this, is if you look at this service, I'm pulling courses in. Now just mentally, just take a snapshot of what this looks like. Now, what I'm going to do, I'm going to go to lessons. Other than the fact that it's very specifically dealing with lessons, this looks exactly the same. Now, don't mistake convention for repetition. I'm dealing with a very specific domain model here. I'm not repeating myself. So doing the same thing and doing things the same way is different. It's an important distinction to make. But this is very much conventional. That if somebody comes in and I ask them to create a new service to pull something from the database, I would expect that they could look at this and they would have a very good idea of what service I wanted them to create. If we go back to state management, so this is using NGRX, that if you look at, we'll take actions. Just take a mental snapshot. I'm loading a lesson, creating a lesson. So this is all CRUD. Also, CRUD is such a fundamental, I think, I call it kind of the four walls of what you do and how you manipulate data and essentially domain models. So kind of just mentally, just scroll through here. And if I go to, what did I do? Lessons? I think I did lessons. If you go to actions, it's the same thing, same exact shape, because it's conventional. If I go to the reducer, and you start to go through here, and then I go to the lessons reducer. I'm just scrolling through. Other than the formatting, this is almost exactly the same. And so now I've taken everything that I've showed you, and I'm basically bringing this back down to nouns, to the very first thing that I talk about with any new programmer, is that when you get this part right and you really understand what this means, that all of a sudden now your most advanced, scalable, enterprisey code starts to have this common theme around it that you can start to accelerate your development and start to automate those bits and pieces, which is why in my case, when I build Angular and React and Node applications, I start with NX, which has a CLI that then defers back to the Angular CLI, the Nest CLI, and it generates major portions of this code for me, because never let a human do what a robot can do perfectly every single time. But when you understand this basic first principle, when you truly understand nouns, and it's just this loop that you can start to take and scaffold your application up in such a way that things that used to take me weeks, it would take me a couple weeks, I can now do in a couple hours. And in some cases, I can produce an entire application in less than 10 minutes using the CLI. And so this is where I leave you. I encourage you, as you start to develop, look for the meta patterns and the common things that you're doing and focus on those. So when you start to see yourself doing the same thing over and over, or these patterns, pay attention to those so that you can either automate around them or you can extract around them. And it's going to make you better, more stable, more efficient programmers. And I cannot wait to see what everybody comes up with when they start to apply this, because this took me 20 years to get here. And I think you are basically reading the back of my book, if you will, is I feel like some of you are at the front of your story. And I'm really excited to see how much further you can take this than I have. So with that, that's everything that I have. Hopefully that was helpful. And yeah, so any last questions? Ashley, if you have any commentary or anything you wanted to wrap up with. Oh, Thomas has a question. All right, I'm ready.
Okay, so basically, I work at a startup at the moment in London, and I've got exactly what you described happening with the cracked foundations in the data model. And we've got, pressure to deliver new features and move fast to try and make the company survive.
Mm-hmm.
How do you deal with that as a developer, trying to bring in code quality and dealing with a product and a software that has a very broken foundation? How do you deal with that?
So I would say you can accelerate your development significantly by identifying the patterns that exist across multiple features and automating them. And so I would say use the CLI to the max. And so whatever, if it's Angular, if it's React, I mean, every major framework at this point has a really good CLI. Leverage that. And so in my case, a lot of times I know what I'm going to generate. Like I know what my app what I want it to be. And so I'll actually write out everything that I'm doing in a single command that I turn into a shell script. And then I just run from the command line. And before that would take me hours to spin up. And now I'm able to just at least, get a major chunk of my functionality right out of the way. Like let the CLI, let the schematics, another thing is use smart templates. If you find that you're actually typing something out more than once in VS Code or whatever, be like, I don't need to do this, like automate this. And I really believe that you should spend 95% of your time around the real complexity in an application, which is from application to application, what changes? Well, in my opinion, it's two things. It's the UI and it's the business logic. That's where 95% of your time should be spent when you're developing an application. The other stuff like the services and Redux and NGRX, automate that. Just lay that down. It's like paving a road, and you focus on the true complexity that changes from one domain to another, and that's UI and business logic. And you find ways, I think as well, this is a really interesting thing that I think this is important as software engineers, is that we are crafts people, that we take, the word is craftsman, but I don't know what the gender neutral form of that is. So I will say craftspeople, is that we are building things that should be excellent. And we do this because this is what our clients deserve. And so in the case of a startup, Thomas, the health of your organization or your company depends on you putting code or deploying code into production that users actually like and that they can use. And so anytime that a client or a boss or whatever ask you to compromise on code quality, that you have to be willing or ready to explain to them why that is ultimately not in their best interest. And when you have that level of trust, you can do that. And that you would, I think a really simple example or a metric that I use is that low quality code versus high quality code, that first of all, low quality projects, and this is I believe the economics of software quality, that this is, you can look it up. Stephen Kensley, I believe, has a pretty good graphic on this, but he just pulled it from the book, is low quality software or low quality projects get canceled 3 to 5 times more than high quality projects. Low quality projects takes 10 to 20% longer, and they cost 10 to 20% more. And so simply on $1 million project, you just have to ask yourself, are you willing to spend an extra $100,000 for me to cut this corner? And when you start to frame it back into business value, I've had a lot of stakeholders say, no, this is not worth making a $100,000 mistake on. And so it's really understanding why we insist on code quality and what it's actually going to cost the company, which is 10 to 20% overage in time and budget, typically. Hopefully that was helpful, that there's not a cut and dry answer, but it's I think it's committing to it, being consistent, and then conveying the value in terms that stakeholders understand.
Yeah, no, that was really valuable to hear. That is massive, actually. And part of that is me truly understanding the full extent of that so I can explain it, because
Right.
I don't even know if I was being fully aware of the degree of the level of impact it can have when you throw those stats my way. So
Right.
hopefully it will actually, a lot of it is actually in my own power as well, as an actual commitment for myself to say, look, this is the standard I'm going to hold myself to no matter
Right.
what.
And I'm trying to find, and I'll send this to, if anybody is interested, I can send this to Ashley as well. It's this right here. This is where I'm pulling this chart from. And again, so I'll attach this to, I'll send this as well, if anybody wants to download, but it's this particular stat that I'm referencing, that where this graph comes from. And it's really illuminating. And when you trot this out and you start talking about money and time, suddenly people that actually have to write checks and be held accountable, suddenly start to take this very seriously. So where is, like, it's just killing me. I can't remember this individual's name. I'm going to paste just this link where I got this from into chats. And that way everybody can see it as soon as I find it. Wait for it. Boom, incoming. All right, there we go. And I recommend Stephen Kensley is, he wrote Docker in Action, 2nd edition with my other friend, Jeff Nikoloff. He is, everything I know about software and cloud came from him. So I would go read everything that he's ever written and then read it again. And so if you see me on LinkedIn or we would connect, like typically he'll post something and then I'll just be like, it's Christmas in July. Like, this is amazing. But this is where this came from.
This was wonderful. Thank you so much, Lucas, for jumping in tonight and sharing your time and knowledge with all of us. Definitely, I learned a lot, and I hope everyone on this call also learned a lot. I will be sending out everything in a follow-up email tomorrow morning, so you will have that in your inboxes. And I did get some questions about the previous talk. We do have that recording on our YouTube channel. I am going to see if I can paste that link into the chat. So if you still want to dive into more of Lukas tonight, you can go ahead and review that there as well.
Oh, snap. All right, it's out in the wild.
Yes. But thank you again so much, Lukas.
Thanks,
this
everyone.
is truly wonderful, and we
Awesome.
loved hanging out with you.
I love hanging out with every one of you. So thanks for this opportunity.